Evening, one and all. My name is Rahul. As a series of lectures, first one is important concepts of VLSI that I have discussed 10 important concepts. Next is nothing but I have discussed regarding the IC density of integration. And in this video lecture, I want to give a big discussion on threshold voltage concept. Threshold voltage concept, that is one of the important concept in the introduction of VLSI. So, what is this threshold? Threshold is denoted as VTH, or you can say it as VGS. V means voltage, suffix GS means gate and source, gate to source voltage. So the minimum voltage that is required to process the current between the gate to source to drain, between source to drain, that is called as an threshold voltage. The minimum voltage that is required to form a channel between source and drain, Channel means the channel will allow the current to flow. So that is the threshold voltage, the minimum voltage that is required at VGS, so that the channel will be formed from the gate to source. The minimum voltage that is required at gate, so that the channel will be formed from gate to source. That is the current flow should be formed from gate to source. Okay, now so that a particular voltage is called as a threshold voltage. The minimum voltage that is required at gate terminal, so that the channel will be formed from gate source to drain. Channel will be formed from source to drain. I repeat, the minimum voltage that is required at gate terminal, so that the channel will be formed from source to drain. That is nothing but channel. In channel, the current will flow. As you know that universal law, Ohm's law. This V is directly proportional to rate of current into resistance, where I is equal to ratio of voltage to resistance. I is equal to voltage of ratio of voltage to resistance. R is nothing but ratio of voltage to current, whereas voltage is equal to product of current into resistance. So this is the thing actually. And what are the factors that is affecting the threshold voltages? First is the doping concentration, we can say. And what is doping means? Doping is nothing but adding impurities to the pure semiconductor. Semiconductor is nothing but it is between the conductor and the insulator. Conductor which allows the current to flow through it. Example is like iron, metal, etc. Semiconductor is something which doesn't allow entire current to flow through it, or now does it stop entire current flow through it. It will be in between, like examples of germanium and silicon type of semiconductors. Silicon is usually in engineering laboratories, mostly not germanium, maximum. Okay, and next is nothing but what it is nothing but a conductor, semiconductor, insulator. First is the conductor, third is insulator. Insulator does not allow the current to flow through it, like wood, plastic, rubber, etc. So next thing is factors that affecting the threshold voltages. First is the doping concentration. Next is nothing but oxide thickness. Third is nothing but channel length. First, doping concentration. High levels of doping concentration will increase the threshold voltage. Next, oxide thickness. If the thickness is more, then it will lead to higher threshold voltage. And the next is the vice versa. That is the channel length. If the smaller channel length results in a lower threshold voltage, that is due to short channel effects. So I have discussed regarding what is the concept of threshold voltage, VTH, V sub H, or VGS, V sub GS. That is nothing gate to source voltage at gate to source. That is the representation of threshold voltage. Okay, now voltage is nothing but voltage at gate to source. The minimum voltage that is required, threshold voltage means the minimum voltage that is required at gate terminal, so that the channel will be formed from the source to drain. Okay, that is nothing but in channel the current will flow. That is nothing but I. Something but a ratio of voltage to resistance. Okay, current basic channel is ampere. Voltage voltage is resistance. That's Ohm. Ohm is equal to scientist. Ohm is nothing but volts. And the current is equal to amperes. Ampere is scientist. Current voltage and resistance. These three play important role in Ohm's law. The factors affecting the threshold voltage is first one is the ultimate see. But in atom, we have electron, protons, and neutrons. Okay, now that is also we can't see. Wi-Fi also we can't see. Bluetooth also we can't see. But we have to analyze transmission waves. When we talk in mobile phones also, EM waves we can't see. Conversion from the sound waves to electrical waves, and again back electrical waves to sound, modulation, demodulation, everything which will be in the air, which we can't see. That is only beauty of electronics. But we have that everything has been done. Everything is like jadoo. So it will be very, very thing. Everything is like magic. That magic should be decoded. What the magic is happening. So magic is converting from one form to another form. No, every energy neither can be destroyed and can be stored. This convert from one form to another form. It's not stored. So everything is some maximum things in physics, some things in electronics, maximum things are not seen. But in microscope, in microscope we can see. To analyze the things which are very, very not visible to our naked eye, but we have to analyze through the microscope, and we have to analyze the things. That is a very basic thing you have to do as a scientist, and as a researchers, or as a student, faculty, etc. So I've discussed regarding the threshold voltage and factors affecting the threshold voltage. That is one of the important concepts in VLSI design. So in next coming video lectures, we are going to discuss more about introduction of VLSI design, fabrication, okay, as well as circuit diagrams, stick diagrams, layout diagrams, and what are the back-end and front-end softwares, how we have to use practically, and what is verification and testing, how we have to test the system designs. Like for example, Xilinx is a test bench to test the system design for verification, etc. All those are the different units which will cover this particular VLSI design syllabus, so that everyone will get a grip of going into basic good company by this basic sound knowledge. So theoretically and practically, it should be very good in order to analyze. But most of the things are unseen by naked eye. That is only the next step. You have to go and understand and see with the microscope and analyze the subject and get into the core of the subject, how it has been decoded. But no one will say how the EM waves will be generated, how it will be transferred, how it will be seen. Okay, now only authorized licensed versions will be there. So we have to go there, industries, we have to take permission, and we have to see how the process is going on. How the process is going on. How the naked eye can see, how the normal person can understand. We have to take it to industry experts to see what is happening. Okay, now in transmissions, which is not seen by naked eye, and to understand the concept, functionality, principle, and etc. That is one more extra step that you have to go in the industry, meet the experts, and go to it. No one will be uploading in YouTube or any Googles. That is a licensed version and a patent version. So that is the input what I will give in order to go to extra step of the VLSI design. So I'm closing this session. Thank you very much for having patience to listen to this video patiently and acquire knowledge. I hope it will be useful for you. I'm closing this session on a happy note. Take care. Bye. Have a great day.